In this video, we discuss about bitwise OR operator. In the last video, we have discussed about bitwise AND operator. Bitwise OR operator is denoted by OR symbol, single. It is denoted by vertical line symbol. If you use double vertical line, it will become logical OR operator. If you use single vertical line, it becomes bitwise OR. Bitwise OR operator takes two numbers and performs OR operation on individual bits of two numbers. OR operation returns true if one of the bits is true, and it returns false if both bits are false. That is the scenario of OR operation. So bitwise OR operator, it performs OR operation on each and every bits of given number. Coming to this example, see here A and B are two bits here. Now we have four values 0, 0, 0, 1, 1, 0 and 1, 1. A or B, this is the bitwise OR operator performed on A and B. In the first case, both A and B, both are 0. Since both are 0, that means both are false. Output is false. A or B returns false value, that is 0. In the second case, 1 is 0, second one is 1. That means at least one of the bit is true. If at least one of the bit is true, then output of OR operation is true. Third case here, one of the bit is true, so we get output 1. In the last case, both inputs are 1, we get output 1. In this fashion, bitwise OR operator performs OR operation on individual bits. We see an example program to demonstrate bitwise OR operator. Now in this example, I have applied bitwise OR operator on 10 and 5. In the second example, I have applied bitwise OR operator on 12 and 1. We see what will be the output of these examples. I will run this program. I forgot to write new line character. I will give new line character. After running this program, in the first case we got output A is equal to 5. In the second case we got output A is equal to 13. We see how we got these values. In the first case, A value is equal to 10 or 5. How this is operated here? First, binary value of 10 is obtained. Binary value of 10 is, I am writing it in 4 digits, 4 bits. This is the binary value of 10. And the binary value of 5 is 1, 0, 1. Now this is only 3 bits. That's why I am adding a 0 value preceding 101. This is one binary value of 5. Now we need to find out 10 or 10 bitwise OR 5. So bitwise OR operator, so we start from right to left. Here 0 and 1, so one of the value is 1, so we get output 1. In the second case, one of the value is 1, we get output 1. In third case also 0, bitwise OR 1, so one of the value is 1, we get output 1. In the last case also, one input is 1 and other input is 0, so OR operator gives output 1. This is the value we get, but this is the binary value, but the system displays decimal value. How to find out decimal value? Already we have seen in the previous example, in the previous video. We multiply all these values with 2 powers, 2 power 0, 2 power 1, 2 square, and 2 cube. We multiply all these values and add them. 1 into 2 cube 8 plus 1 into 2 square 4 plus 1 into 2 power 1 2 plus 1 into 2 power 0 1. Finally we get value 15. In this fashion we got the first output, A is equal to 15. Then what would be the second case? A is equal to 12 or 1. We see how we got 13. The binary value of 12 is 1 1 0 0 and the binary value of 1 is only 1. We add 3 preceding zeros and we perform 12 or 1. In the first case 0 and 1, one of the bit is 1, we get output 1. In the second case both are zeros, we get output 0. In the third case one bit is 1, we get output 1. In the next one bit is 1, we get output 1. This value becomes 2 power 0, 2 power 1, 2 square and 2 cube, and we multiply them and add them. 1 into 2 cube we get 8, 1 into 2 square we get 4, 0 into 2 power 1 we get 0, 1 into 2 power 0 we get 1, and final value becomes 13. In this fashion we got the second output, A is equal to 13. This is how bitwise OR operator works. Now what is difference between bitwise OR operator and logical OR operator? We see here. Suppose instead of using bitwise OR, if I use logical OR here, we see what output we get. I am using logical OR here, 12, logical OR 1. How logical OR operator works? It works on the entire value. For logical OR operator, 12 is the entire value, 12 is the true value, so it returns 1, and 1 is also true value, it returns 1, 1 or 1, so it will be 12 is treated as true value, that's why it is treated as 1, and 1 is treated as true value, that's why it is treated as 1, 1 or 1, 1 logical OR 1, it will give value 1. Therefore 12 logical OR 1 gives value 1, but 12 bitwise OR 1 it will give value 13. In this fashion bitwise OR operator and logical OR operator differs from each other.